All right, we have several slides today, starting with 48 to 86. We won't be able to get those done in one day, so we'll split those up in today and tomorrow. Then that gives you just a worksheet then for your remote learning assignment on Friday. So we'll be working towards that, and we'll go from here. All right, organic versus inorganic. Organic molecules are the molecules that make living things. They're mostly made of carbon, hydrogen, oxygen, and nitrogen. They can be built by living things and non-living things. Inorganic molecules can participate in the metabolism of living things, but they do not build living things. Your body has inorganic molecules, but you are built from organic molecules. Organic molecules are generally large and always contain carbon. Inorganic molecules, on the other hand, are very small and generally do not contain carbon. Inorganic molecules, water, there's no carbon in H2O, so it's inorganic. Ammonia, NH3, there's no carbon there. And carbon dioxide. Now, what do you notice about this one? There is carbon in it, but carbon dioxide is inorganic, so that's kind of like that exception to the rule. Even though CO2 has carbon, it is still considered inorganic. Carbon is special. Carbon atoms can have 4 covalent bonds. Carbon atoms can bond together to form long-branching chains, allowing organic molecules to become large. Large organic molecules have carbon-containing backbones, also called carbon skeletons. Trace the backbone in the fatty acid molecule below. Okay, so carbon, 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 carbon. Okay, you can clearly see that's how they're bonded together, is with the carbon. Organic versus inorganic. There are 4 categories of organic: proteins, lipids, carbohydrates, and nucleic acids. Organic versus inorganic. How big are they? A typical lipid molecule is made out of 100 to 200 atoms. A DNA molecule can have more than 1 billion atoms. Organic molecules. All life on Earth is built from organic molecules, which are often large and built from many smaller building blocks. Large organic molecules are called polymers. Poly means many, and mers means units. Individual building blocks called monomers. Individual building blocks. Brick walls are built out of many bricks. Organic polymers are built out of many monomers. Monomers and polymers. Use the picture below to define a monomer and a polymer in your group. We'll just do it out loud together. John, your eyes should be up here. Alright, so a monomer would be one thing, and then a polymer is many of those monomers stuck together, okay, to like make a chain or connect them together. Amino acids. These are monomers. They're linked together to form proteins, which are polymers. If you unravel a protein, you will have a chain of amino acids. So all of those amino acids stuck together make a protein. If a protein is like a brick wall, then the amino acid is like what? The cement, the ground, a brick, a building. Anybody? Go ahead.
A brick.
A brick? Sounds right to me. Which of the following is an organic molecule? CO2, H2O, protein, sulfuric acid. Which one?
Protein.
Protein? Sounds good to me. Organic molecules are large because of the ability of carbon to form chains of various sizes and shapes. Is that true or false?
True.
True. Only living things can synthesize or build organic molecules. True or false?
False.
Organic monomers formed. But where did the organic molecule come from? We don't have a definite answer to this question, but we will learn about three hypotheses that scientists can test. Arrival on Earth from space, formation on Earth through chemical reactions in shallow oceans, and formation on Earth through chemical reactions near hydrothermal vents. Theory 1. Organic monomers from space. The dust in the solar system from which Earth formed was rich in organic chemicals. Meteorites striking Earth would have hit with lower velocity since the atmosphere was thicker. The monomers would have survived. All right, let's watch a video. Maybe.
Technology took astronauts to the moon and back, from outer space to inner cells. When engineered solutions are needed, we are there, pushing boundaries and delivering tomorrow's capabilities. We are Draper.
But what could cause comets to fly in from the furthest edges of the solar system, slam into Earth, and deliver these organic compounds? The clues to one possible process lie back out in the Kuiper Belt, the disk of icy objects that orbits the sun at the edge of our solar system.
We expected when we found the Kuiper Belt that we would just see objects in nice circular orbits about the sun.
But observations revealed that the Kuiper Belt objects are not orbiting as predicted. Out here, it's chaotic.
When we look at the Kuiper Belt, we see something that looks like somebody took the solar system, picked it up, and shook it real hard. And that's what started us thinking that something really strange is happening.
Levison theorizes that the reason for this mayhem likely is connected with the two largest planets in the solar system. Jupiter is so big it could swallow more than 1,300 Earths.
Dr. Bell.
And Saturn, with its vast ring.
All right, we'll stop for today and we'll continue tomorrow.